What's good, my fellow GeoGeeks and MetaMappers? Spatial Ninja here, bringing you This Week in MetaMapping. Now, this week we've got a few geospatial articles to cover, but one big news announcement that we'll spend a good amount of time discussing is Apple's Vision Pro product announcement and how this AR/VR headset could impact the GIS and geospatial world here in the near future. But before we get to that, we do have a couple articles. One that talks about how satellite imagery providers are moving into a 30 centimeter resolution imagery capture and how that is going to transform our industry. We've also got an article talking about digital twins in the San Francisco airport. And then another article which discusses some of the AR/VR challenges today, which will then lead us into how Apple's new product may help to address some of those challenges. And as always, we've got a MappyMeme of the week that we will show, and we'll also talk about some of the new updates to the Meta World Maps NFT projects. So with that, let's jump right into the first article. This article comes from GeoAwesome. A revolution is coming in satellite imagery. Why 30 centimeter satellites are set to transform our industry. So there's the emergence of 30 centimeter satellite imagery capture. The ecosystem is seeing established operators launching next-gen 30 centimeter satellites at a staggering rate. And this is augmented by newer players who are scaling up their low resolution satellites to take advantage of this new technology. So this combination of existing fleet upgrades from incumbent operators as well as these new satellite emerging players will result in nearly a 10x the number of high resolution satellites in orbit by the end of the decade. Forecast to be more than 100, which is pretty crazy to think about, knowing how many satellites are already in orbit, if we're going to see an increase in new satellites, as well as some of these existing satellite operators upgrading their satellites to be able to capture this high resolution data. So here we have this chart that shows us some of the satellites in orbit and those that are planned, as well as who the operators are, Airbus, Maxar, Planet. Some of these are well-established players, and others are kind of emerging players. What satellites they plan on launching, as well as kind of what country they're launching those satellites from. So why is 30 centimeter data that important? Well, 30 centimeter satellite imagery represents a significant leap in image clarity and detail when compared to 50 to 70 centimeters today, not to mention the lower resolution data. So this higher resolution and image clarity afforded to us by this new tech will allow users to identify objects and features on the ground with much greater accuracy, which then opens up a whole range of new use cases. So I think we're all pretty used to leveraging aerial imagery in our base maps when we do our GIS work, or even if we want to just open up Google Earth or take a look at where our house is and take a look at the imagery. We're all used to looking at aerial imagery and wanting the latest and greatest aerial imagery, as well as wanting that high resolution imagery. So this 30 centimeter satellite imagery, think about the different use cases there. One, you're just going to have a better quality aerial imagery base map for your GIS data to overlay on top. But one of the emerging use cases for machine learning on the GIS side is around object detection. And so a lot of organizations, a lot of GIS professionals are using aerial imagery and training deep learning models to detect certain things in that aerial imagery. Like if you want to detect damage after a recent hurricane, you could train models what damage looks like and then run those models against imagery that's been captured right after that hurricane so that you can automatically detect those locations that have sustained some sort of damage. So being able to do some of that machine learning object detection with 30 centimeter satellite imagery resolution, your models are just going to be that much more exact, and there's a lot more that you can start to detect in that imagery, more kind of smaller objects that you'll be able to detect. Okay, so what are the challenges with collecting this higher resolution data? So we see here business process that are resistant to change. So, some AI algorithms that are already used to leveraging some lower resolution data, those business processes need to change. Again, some processes like your aerial imagery base map, 30 centimeter resolution, maybe you don't need that high of resolution for your maps. So there will be some resistance to change, trying to find use cases that will leverage this 30 centimeter resolution data. Data storage and processing, I think that's kind of first to my mind in terms of a major issue. When you capture higher resolution data, the amount of data that you're dealing with increases drastically, and how are you going to store that data, and the amount of time that it's going to take to post-process that data is going to increase as well. Bandwidth and transmission. So, transmitting that data from those satellites back to Earth requires bandwidth. Again, when you have that much data, you need more bandwidth. Cost of access. So, this 30 centimeter data, when it's first released, is going to come with a cost associated with it, and then integrating into existing systems. Again, those systems that leveraged lower resolution data in the past, now you're integrating with this higher resolution. There's that data, there's that processing, and the hardware infrastructure to manage that data that goes along with it. So definitely will be some challenges, again, as we have more and more high resolution aerial imagery data, satellite data, drone data, and just GIS data in general. But with that will come an increase in different types of use cases for this higher resolution aerial imagery data. Moving on to our next article this week from the Esri blog, Geospatial digital twins offer unmatched clarity for complex systems. So a complex system of geospatial twins offers the opportunity for unparalleled clarity and analysis. So some of the key takeaways from this article: digital twins are now common across a variety of industries and public sector applications. If you've been watching our MetaMapping episodes, you'll know that week in and week out, there's continued articles around digital twins and metaverse, and they're still becoming more widely adopted. And with that, the GIS is being heavily associated with digital twins, since if you're mapping the real world as a digital twin, GIS is a great technology in order to do that. Geospatial digital twins offer the optimal model for any use case. As we know, there's different layers within a GIS. So as you're modeling the real world, you have environmental layers, you have infrastructure layers, you have building layers, which are all different digital twins in their own right that are being modeled in the GIS. And geospatial digital twins are a key reason for the explosion in the number and variety of the form. So GIS is allowing folks to really put these geospatial digital twins to work and start to see things with an increase in resolution. So instead of looking at this data just on a 2D map, now you're starting to move into that 3D world. So this article basically talks about the San Francisco International Airport. and how they're starting to map out all of their infrastructure using BIM models, as well as layering in GIS layers to give folks that are traveling through their airport things like indoor routing and an understanding of where restrooms are, where restaurants are. But from a facility management side, the airport is able to better manage their facilities with this kind of digital twin that they're starting to build with BIM, with GIS, that we can see here, some of the images. So GIS can produce realistic digital twins because the technology can now seamlessly integrate immersive 3D environments, including details obtained via drones and reality capture techniques. So like we've talked about previously, taking the GIS data, those 3D models, and then layering on top all that drone or reality capture data, which then gives you that more realistic look and feel of your 3D models. And geospatial digital twins can go further than these 3D models by adding the dimension of time. Like the systems they mirror, digital twins evolve by compiling information regarding the past and present. Digital twins can be used to query what happened, when, and even what's likely to happen based on past patterns. So again, this is somewhat common GIS spatial analysis, being able to model what has happened in the past so you can do some forecasting and prediction on what is going to happen geographically in the future. Revealing trends and doing hotspot type of analysis. You can see a few more screenshots here of these 3D environments. So again, just another article that highlights a use case for digital twins. In this case, it's really focusing on the San Francisco airport here, but an emerging space for all of us in the GIS world. Next article from GeoWeek News, a key challenge with AR and VR, getting people on board. How are the challenges in implementing AR and VR on the job site being overcome? So implementing new technology for data visualization, such as augmented and mixed reality, poses unique challenges. The integration of these advanced technologies requires overcoming obstacles related to hardware capability, data processing and interpretation, user experience design, and privacy and security concerns. So if we think about the current augmented and mixed reality space, you've got new hardware coming online, like the Apple Vision Pro, which we will talk about here in just a minute. But you've got some existing technologies like the Meta Quest and the Oculus now, which provide kind of a VR type of experience. But if you've used any of those types of headsets, you know how big and bulky they are. And there's not a lot of kind of real world use cases for them. So the adoption of this augmented and virtual reality, one, the hardware just isn't quite there yet, but then also the software, you also need fast performing software that goes along with that hardware, like the GPUs that are within that hardware to be able to process that image very quickly. And you also need the data aspect, right? So you need the GIS data mapped out. So if you are doing augmented reality, you've got very exact GIS data, and you're able to kind of triangulate so that if you're looking at a manhole on the ground, your GIS data is lining up there, and whatever you have as your headset can show you the manhole, and you have your GIS data lined up. If you have inaccurate GIS data, or the headset's not triangulating properly, then it's going to show your GIS data way off to the distance, even though the manhole is right in front of you. So there's been a lot of challenges with the hardware, the software, and then really some of those use cases for augmented reality. So a couple of quotes here around some of these challenges. One from Emily Ullman, CEO and Chief Media Officer at Hopscotch Interactive. The challenge is that you typically will have one or two pioneers at a company or people whose job has an element of innovation strategy in them. At the earliest stage of trying to get buy-in at a company level, one of the problems is, let's do a proof of concept. Let's do this slow, very old school way of onboarding and testing. But in many cases, the coolest, newest, most innovative technology is probably not going to survive waiting for your $20,000 proof of concept every 6 months. If you really want innovation to happen quickly, I think you need to be able to assign more resources to it and not just have one guy who spends 10% of their time on innovation. So this quote basically just talks about the adoption of some of these new technologies in the workplace, right? So if you work for like a construction company, I'm sure your construction company is not adopting augmented reality today. Maybe somebody has bought a headset. Maybe someone has an application on their smartphone that has got an augmented reality app using the camera, and that one person is playing around with it. Maybe you're putting together a proof of concept to test that out. So this quote and what Emily is trying to say here is that innovation needs to happen quicker and adoption needs to happen quicker in order to have some of these new use cases really adopted in our fields here. Another quote, currently for us, one of the most difficult things is that there are so many different types of data collection solutions and workflow that it's hard for us to wade through the weeds of what should be implemented for our work. Then you need to figure out a way to bring all that data together to provide an end deliverable that meets our needs. So, with this quote here, as new technology emerges and comes online, there's lots of different players out there and lots of different applications. So what is the best app for data collection? What's the best app for augmented reality? Once you are using some of these, you are collecting data, how do you then put that data to work and get that to the back office and find an actual use case for going out in the field, collecting data through an augmented reality application. Another quote here, educating our staff on innovative solutions is key as they are most often the ones that are able to see better way to do something within their current workflows when presented with these new ideas. So another challenge that they have here is around educating their staff. So some workforces may be used to performing analysis, collecting data a certain way, and when you start implementing or you start putting out there these newer technologies like augmented reality, you need to educate your staff so that they feel comfortable enough going out and adopting some of these new technologies. So a lot of these articles and in this report here are about how more businesses are finding a challenge with adopting AR and VR. But I would also say that on the consumer side, it's been a bit of a challenge, specifically with VR. I think that VR technology and VR in general is still a ways off. Just like metaverse, it is coming, but there's not a lot of great use cases today, right? The graphics aren't quite there, and the applications just aren't compelling enough, right? Going into a virtual headset to go to a virtual concert and seeing all the other little virtual people around, I would still much rather go to a in-person, real-life concert than putting on the VR headset and being remote. Now, with that being said, I do think that some of the AR applications that are coming out will be more compelling. which does start to bring us into our next article here about Apple unveiling Vision Pro, their AR/VR headset, which is their first new major product in a decade. Now, as we go through this article, what we'll see is that a lot of the applications and what they were promoting and highlighting in the kind of Apple release of this was around more augmented reality use cases, right? Being able to see through the headset and then put inside of an augmented space a TV screen or multiple screens, or be able to interact with things around you while still being able to see completely through the headset. So that augmented space versus completely putting on a headset, not seeing what is in your space and being more in that virtual space. So it's interesting to see that Apple, what they're going after first is more of the augmented reality use cases versus the traditional kind of VR. You're completely immersed in some other world, which I think is a smart decision by Apple. And there's more consumer use cases today for that than traditional VR. So after years of hype, Apple on Monday unveiled its much anticipated mixed reality headset, the Vision Pro, the tech giant's first major new product since the 2015 Apple Watch. From Tim Cook, this is a day that's been years in the making. He believes that augmented reality is a profound technology. Again, highlighting augmented reality. Now, there wasn't a lot of discussion or even mention of metaverse or virtual reality in that release of the product. A lot of what was talked about was augmented reality. The headset, which Apple calls a spatial computer, has two screens inside with a total of 23 million pixels and a wire connecting the goggles to a battery pack that fits in the pocket, which can power it up to 2 hours of use. So I've seen this a few times that Apple referring to this as spatial computer. Again, when we think about augmented reality and understanding where things are in relation to you, so that you can have a virtual screen there and a virtual screen there, and you can interact with a virtual keyboard, it does need to rely on your placement and the placement of other things. Again, where GIS is going, where location intelligence is going, this idea of spatial computing and augmented reality. As far back as 2016, Apple filed patents for this lightweight eyeglasses and a bulkier device, but while Cook reportedly preferred the more compact option, so originally they filed patents for lightweight glasses or your more traditional VR, bulkier style headset, there were some technical challenges that forced Apple to change its strategy and go with a slightly more bulkier headset. Now, I will say, compared to something like the Quest VR, it's a lot lighter and smaller of a device, but it's not like the Google Glass style headset. It says in Facebook, 2014 bought the startup Oculus for $2 billion and has released 2 generations of its Meta Quest, which is mostly geared towards gamers. Microsoft in 2016 made a big bet on the HoloLens headset, a 3D augmented reality device, but it failed to gain traction with consumers. And early on, Google made the buzziest splash more than a decade ago with the disastrous Google Glass, which was a sleek headset with a camera on board. So again, with a lot of these devices, you're seeing the hardware and software not quite being there, right? The data, the applications, the use cases not quite being there yet. Whether it's just because headsets are too big, right? Here we can see people often complain about the headsets currently on the market, that devices overheat, they're too heavy to wear for too long of a time, or they become uncomfortably sweaty on the foreheads. Others have found the experience of being disconnected to the real world and immersed in full-on virtual reality for long periods of time too isolating. So, you've got devices that today are just too bulky. These companies that have gone straight into virtual reality, people are saying that being in this virtual space for too long, it's too isolating. So Apple's approach to go after augmented reality, where you can still see through the device, but place these virtual screens around, again, I think you're going to see more adoption of this style of headset today. Now, will one day we be completely in a virtual reality space and it will be more widely adopted? I think so. But I think to get people more into VR, we need to start with AR. One important thing here too is that Apple also showed off its partnership with Disney, announcing that Disney Plus streaming service would be available on the device at launch. So content, applications and use cases, right? Another issue again with the VR headset is just different applications or uses of it. So if Apple is able to partner with content providers so that you can sit on your couch and basically have a movie theater style screen pop up without actually buying a large TV or a projector, and they've got really good content, the visuals are really good. Again, I think that folks are going to find this headset very compelling, although the price is very, very high. So with really good technology comes a cost. So it'll be interesting to see if normal consumers like you and me are willing to pay $3,500 for these headsets. But as technology advances, as years go by, the tech will become cheaper. And I think you'll start to see more and more folks buying these headsets for cheaper prices, with these augmented reality use cases being that kind of first set of use cases that Apple is going after. Very interesting to see how all this space is been evolving, and again, where GIS, where location data is starting to come in, location services being able to provide real-time location data and help with understanding space awareness for augmented reality. So let me know what you guys think about Apple's new Vision Pro in the comments below, and where you think GIS is going to have a role. And do you think augmented reality will, maybe the Vision Pro will kind of kickstart this new augmented reality drive, and we'll see more and more applications come on the line? Let me know in the comments below. Okay, so let's move on to our MappyMeme of the week. Now, this MappyMeme comes from Small Town Mapper. The Monday after it did improvements to the network. IT did improvements to the network. The all caps got me there. Yeah, so Grumpy Cat, not liking this. So I remember the days of IT saying, yep, we've improved the network, we've made updates and installs. You get in there, you start logging into the server, and everything's still as slow and clunky as it was on Friday. So Grumpy Cat not liking that on Monday. So let's go ahead and like and retweet this MappyMeme. So that's our MappyMeme of the week. This has been another episode of MetaMapping. This is this week in MetaMapping. Be sure to come to our YouTube channel and subscribe and like this particular video. We've got lots of other videos that we've released, some tips and tricks on ArcGIS. We've got another video that will be coming soon, specifically on some AI generated images, as well as we're going to talk a bit about ordinal NFTs on Bitcoin. So if you're into Web3 and the crypto space, be sure to check that video out. And from our last video, remember, we're giving away a Ledger Nano X and a MetaWorld Maps hat once we hit 50 subscribers. So if you haven't subscribed to our YouTube channel yet, please do so. And the last thing for today, we've been doing some updates to not only our MetaWorld Maps website, but some of our NFT projects, including our Project Meta Expedition NFT project. One recent update is that we have released new Meta Explorer Club badge NFTs. So if you're familiar with our Project Meta Expedition NFT project, if you acquire our map parcel NFTs, you have a chance at gaining entry into one of our Meta Explorer clubs. Entry is based on the number of map parcels that you have acquired that has a specific GIS feature in it. For example, our Mountain High Club, if you acquire 5 map parcels that have mountain peaks in them, you'll become part of the Mountain High Club, and we'll airdrop you one of these Mountain High Club NFTs. You can come on to our leaderboard map here and see all of the map parcel NFTs and who has acquired which NFT and whether or not that map parcel allows you to gain entry into these specific clubs. So if you want to track your progress as you are acquiring these map parcels, be sure to check out this leaderboard. But as we can see here, we've got these new NFTs ready to be airdropped. So if you have been tracking Project Meta Expedition, if you've got some map parcels, now we've got these new Meta Explorer Club badges. So be sure to go ahead and mint your very own map parcel NFT today. So this has been, again, another episode of MetaMapping. Appreciate you all watching and checking this episode out. And as always, stay mappy, my friends.